Let's see. Today our topic is to find the expression for the drift velocity. For finding the expression for the drift velocity, first of all we need to understand what is drift velocity. For understanding it deeply, we need to consider a conductor. Let this is a conductor. When no potential difference is applied between this conductor through an external source, then the electron these are the electrons in this conductor. These all are the electrons in this conductor. So when no current is applied in this conductor, the potential difference is applied in this conductor, then the electron have the motion in random motion. The electron in this conductor have random motion in this direction and this direction. So the net charge upon this net charge on the conductor is equal to 0. Force net is equal to 0. But when an external source, let this the external source, through we apply the potential difference between this conductor, so and this is the positive terminal and this is the negative terminal. Then when we apply the potential difference between this conductor, then the electron in this conductor becomes move in a uniform particular direction. Let I amount of current is flow in this direction. I amount of current is always flow from positive to negative. I amount of current is flowing in this direction, then we can say that the motion of electron is always negative to the motion of current. Then this is the motion of current and this is the motion of current and this is the opposite motion of electron. Now for finding the expression for the drift velocity, first of all we need to define some term. Let n be let n denotes the total number of electron. n be the total number of electron by volume of the conductor. Let n be the total number of electron in this conductor and b be the volume of the conductor. Then we simply get that n is equal to nv. Let it be equation 1. Now let's talk about the charge in the conductor. Charge is equal to total number of electron in this conductor. We have suppose n, then n be the charge on let n be the total number of electron in this conductor into charge of electron. Let E denote the charge of electron. Then we can write that q is equal to, from this expression, from equation 1 we can write that q is equal to nv into E. And I amount of current is flowing in this circuit, and so we know that the current is by the definition of current, total number of charge flowing per unit time. So we can write that q is equal to it. From this expression we can write that q is equal to it. So I amount of current is flowing in this conductor, so I t is the total number of charge in the conductor, and it is equal to NEV. So current is equal to NE, and this is the volume of the conductor. So the volume, if A be the area of the cross section and let L be the length of the conductor and A be the area of the conductor, so we can write instead of volume, area into length by time. So we can simply write that I is equal to NEA into L by T. So the expression the term L by T denotes the velocity in this conductor, and we have supposed that the velocity of the conductor is v drift. This is the drift velocity of the conductor. So I is equal to NEA into Vd. Let us see that when a potential difference is applied between this conductor, then the electron has get some acceleration in the conductor. Electron in the conductor has get some acceleration, and the electron accelerated through some velocity, through some acceleration. then the acceleration when it collide with when this electron collide with this electron, and this electron collide with this electron, and this electron collide with the lattice side of the conductor, then its velocity become then its sorry and then its acceleration is reduced and it finally acceleration tends to approximately equal to 0. So in this case the velocity becomes uniform in this conductor, and this velocity we talked that in this is the drift velocity. So we can say that L by T is equal to drift velocity, and we simply get that I is equal to Vd is equal to I upon NEA. This is the expression for the drift velocity. We can also derive the expression for the drift velocity in the terms of electric current density. Current density is that J is equal to total current upon area. Total current upon area. So I is equal to J into current density into area. So the drift velocity can be written as Vd is equal to J current density into area upon NEA. Then this cancel, so we can write that Vd is equal to current density by Ne. This is also the expression for the drift velocity in the terms of current density. Let it be equation 4 and 5. Thank you.